Okay, thank you for watching. This will be the first of 5 videos which will be explaining how I created each of my generative music experiments. This will be the video for the first one, which is I'm calling Loop Choir. But first, before I do that, I just wanted to explain a little bit about why I ended up choosing this particular device, the sequencer, the compulsion sequencer arpeggiator, as opposed to some of the others. So for a long time in my blog posts and everything, I was considering a utility. The utility is made by the same company as the compulsion sequencer arpeggiator. The utility was called the PSQ1684 pulse sequencer. And it's similar in some ways and different in others. So for starters, it doesn't have a big display showing you exactly what's happening. But it has a lot of other really, really great things that it can do. So if we, for example, we create a Thor, and then we reset this device. And now what we can do is we can take Thor, take the gate and CV, put it into sequencer 1, which corresponds to this one here, sequencer 1. I just need to move back over here, make sure this is muted. Okay, and then this is automatically set to a division of 1, pattern 1, which means that it's just using this square here. And now if we push play on this, you should just hear a noise, a kind of beep, 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 beep over and over. Okay, so far so good. So what we can do, this is actually going along these lines. So what we'll do instead is we'll change this so that it's only going to W8. So basically, in other words, it's just going along here and then it goes back around again. If we change these notes, you'll hear when we push play again that it will change its pitch. Okay, now we can actually conform that to a quantizer here. So let's say we just wanted to conform it to this one that's already pre-set up for us. So let's just do that. Okay, now you'll notice that it will just be hitting only these 2 notes, but it will be hitting, I guess, multiples of those notes, or the next octave up of those notes, I should say. Okay, so here it is. Okay, so you can't really hear it going up multiples, so if we put it up here, you will though. Okay, so far so good. Now, the way that we get extra sounds in there, so this only allows, one pulse only allows 1 note simultaneously. So the way that we could build up chords is we would have to actually make another Thor or another device, another instrument. So let's say we wanted to duplicate this. Oops, I didn't mean to duplicate that one as well. Okay, and now if we go into here and we make the sequencer for number 2, let's change it so we turn the sequencer number 2 will be on row again, so it'll be going along and along and along, and then we'll change it so it's on its pattern A2 or source A2. Okay, so source A2, we'll do this, instead of being a division of 1, we'll have it be a division of 4, so it's not playing quite as often. We'll have it that, as opposed to the W1 to W8, we'll have it be that this is from X1 to X8. So it'll be playing on this row instead, and we'll just have it be that this is all lower notes. So it's kind of like our bass line. Alright, so that should be all set up now. So if we push play, it should play both of them. Okay, so far so good. So that's a really, really good way of making really, really, you can make extremely complex interweaving melodies that way. Problems came along though when I started thinking, but if I'm thinking through this through the lens of ambient music, I would like it that rather than just repeating the same thing over and over, I would like it that it occasionally would sort of stop and then start again, and then stop and start again, or rather it would land on a note and it would kind of trail off on that note, or it would hold on that note for a particular amount of time, and then it would go back to normal. So you can actually do that. So if we take, for example, if we go back to the pulse 1, what we can actually do is change this width here. And so if we just play this a little bit and you use this width control, you'll notice that it will kind of stop on particular notes. Okay, so that's a really good way that you could do that. The problem is though, is that the only way that we can control that is through the modulation matrix. So for example, I would like to do that with CV. So if I created some CV, and then I took, let's say, the pulsar. Now let's change the rate so it's a little slower, and let's make it a little deeper. Okay, so now if we take this, we plug it into the modulation matrix, into number 1, and then we go up here to the modulation matrix. We set so that the CV1 is going to be changing the pulse 1. What was it? The pulse width. You should do it that it's changing it. Let's just make it nice and obvious. So it's changing it at 84 amount. We can do it that it sets, the width is already here, so yep, it'll be changing quite a lot. Okay, so now you'll notice that it will open and then it will close and then it will open and then it will close. So it'll go to being nice and wide, and then it will kind of go back again. You won't actually see it changing on this, but you will hear it. So well, that's not quite working the way I was hoping it would. Okay, so let's turn this up, and CV1 width, maybe we need to make this deeper. And then we've turned this up a little bit, maybe this will work. Oh, there we go. Okay. Okay, so that's getting a little closer to, you know, the kind of style that you might use for ambient music, where it stops occasionally and things like that. Another thing which is really good about this device actually is that I can choose that even if we don't have that plugged in, that what you can do is you can make it so that it occasionally drops notes as well. So you can add just this chaos control. So what all that means is basically probability. So there's some chance now, there's roughly 60% chance that it will hit the note and 40% chance that it won't. Okay, so it'll be a little something like this. So let's just mute this one so that you can hear what's happening with just the original. So you can see that's actually skipping notes. So that's another kind of good thing that you can do with this device. The problems with this device really came along when I started thinking about chords. So as you could hear, these were playing notes. So basically, you could have it that these were running at the same rate at both of these two Thor devices, and then you could have it that that you know, they were landing on different notes at different times, thus creating chords. But the problem is that I'm essentially limited by how many options I have here. And then for each time I wanted to create an extra note on the chord, I would need to create an extra instance of Thor or some other device, some other instrument. And so it eventually got to this point where it was hard. My sort of imagination ran past the capabilities of this device in terms of creating chords. So I imagined, well, what happens if I want to have 16, like for example, my hold and division, the last of the 5 generative music experiments, that has 6 synths, which each have a possibility of hitting one of 16 possible notes at any given time. And so you can just imagine how much that would take to coordinate. So I basically need 16 of these all plugged up to one of these, which I don't even think is possible to begin with. No, it isn't, because it only allows 8 sequences anyway. So let's say it's 8 though. So I'd have 8 of these plugged up to one of these, and then I would need 6 separate stacks of this in order to get that same result that I could do much more easily with another device. So basically, that's what ended up happening. It just sort of the options I felt were a little bit limited on this. It's really, really good for some things, like for example, this modulation matrix is very complex. And it's really, really good for example, you can do not only row, but you can do things like a Klee sequencer, so you can get more of that Euro rack type sound. And it's also really good for triggering drums using something like this. But it just wasn't the exact device that I wanted to use. I knew that there'd be better options out there. So basically, after I experimented with this for a number of hours, I basically decided to move on. The next one I moved on to was an instrument by Robotic Bean. It's called the Step Notes Recorder. So this is a really good device. It's very transparent, which is a good thing about it. So what you can do here is you can see this is the UI for it. And then what you can do is you can just push this record button and bring up this on-screen piano. And then you can just play a melody. So let's say we play something like that. And now when we play this back, it will sound like this. Oh, so I might have to play it down here. But so let's play this back. Oh, this one's still going. Let's mute those. Oh, that one's not playing. Why wouldn't? Oh, of course, we don't have it plugged into anything. Okay, so let's just get rid of that, and let's get rid of this and plug this one into here. So it's still going to be this Thor sound. Okay, so now we've got this all set up. Let's give it a go. That's still it's muted. Okay. Okay, so far so good. You can actually use a quantizer, just like what you could with the previous device. So we can quantize this, so it's in this, let's say, a Lydian style, something like that. Okay, so now if we play that again. Okay, so far so good. Now you can have 32 steps on this, which is great. Another thing about this as well is that you can see everything that you're changing. So if we go back to this LFO, and then we add an LFO to the width, like what I was trying to do before, you can actually see that the width is changing on this, which is absolutely fantastic. And then you can take the same thing too, and you can also change the velocity. So the velocity and the width are also changing, in this case at the same rate. But if you move it over to here, to this other LFO that I've got on this device, and then you turn on this other LFO, turn it down nice and slow, nice and deep, you can have it that the velocity is being changed by this one, and then the width is being changed by the first one. So you can just imagine the amount of possibilities. So that will sound something like this. I don't think it will sound so great, but you'll get an idea. Okay, so basically that's what it sounds like. So that's getting closer to this generative thing, where it's essentially just designing itself, or like the sound is there's lots of happy accidents with the sound. Okay, so the problem with this one was that although it has this really transparent way of you being able to look at it, one of the problems with this device is that it only allows one device simultaneously. So as opposed to the one above, which allowed 8 possible devices, this one only allows 1. So what you would have to do is you would have to create essentially, let's say, 8 of these. And then you would need to create, like, say, 8 Thors, and then 8 of these, and plug 1 Thor up to each one, and then design it that way. And then that would be nice and clear and really good. But yeah, that takes quite a lot of setup. So essentially what happened after that is I started looking for other options. Eventually, I landed on, I'll just mute that. Eventually, I landed on this device here, which is called the Compulsion Sequencer Arpeggiator. Now, the good thing about this one is it allows one device, so in this case, this women's choir, it allows this you to play 16 simultaneous notes from this one source. And so as opposed to this other one where you need to plug up different Thors to get different sounds, to get different notes, simultaneous notes. So this one allows 16 simultaneous notes from one single instrument. So that's really, really good. It's basically done through this gate system. You can also change the note that is being hit through here. for this note octave section. You can change the velocity, you can change the length of each note, which is of course being determined by this rate. You can change the octave, where for example on a particular point on the sequencer it goes up 2 octaves or down 2 octaves. You can use delay, which I didn't end up using much because it was a little confusing, and it was sort of I think there's it didn't really work for the sort of thing I was doing. You can also do hold options, where for example you can hold for a particular amount of time. So that's very similar to what we were doing earlier with the width controls. So you can choose it on a particular point, it will hold for that particular amount of time. That shows you how long it will hold for. And then finally you can choose the note length, which is extremely important for, not the note length, the loop length, which is extremely important for what I'm about to show you. You can choose the direction, whether it's going forwards or backwards or in a pendulum style or random. You can do multiple, so one particular sequencer here is going faster than all of the others, or in this case slower than all of the others in the division. You can actually send out to an auxiliary, so this is not an auxiliary in, it's an auxiliary out. So what that means is that you can control, for example using this, you can control how much of a cutoff frequency is of some other device, or you can control how much feedback of a reverb there is of some other device. So this is also very flexible. But then finally, this one is, as it looks, is extremely complex. And this one, what you can do is one particular sequencer can modulate other sequences. And so that's a really, really, really good thing to be able to do. Okay, so for example, you could have it be that the gate, or rather the velocity of sequencer 1 is being modulated. So you have to just turn this up to the modulated. It's being modulated by sequencer 5, for example. Now, I didn't end up using this much in the end, but it's extremely flexible. So anyway, that's why I chose this device. Okay, so now getting on to actually what I did for this first generative music experiment, the loop choir experiment, is that I basically had 6 simultaneous possibilities, and then I had this looping system, so they would all be looping at different rates, and that was essentially it. Now this is actually a mimic of 2/1 from Ambient 1 Music for Airports by Brian Eno, where he did this same thing. He did it with tapes, and he would have several tapes, and then he would be playing them at different rates, or rather they would be looping at different rates. And so this is a similar sort of thing. So if you just imagine this one, the sequencer 1 is looping all the way to the end, whereas sequencer 2 is looping a little bit less than that, sequencer 3 a little less than that, etc., etc. And basically what happens is you end up getting this pattern where the first time through all of the notes play at the same time, but then after that they all play at different rates. So if we have a bit of a listen to that, we can hear that now. So you can actually see these are all the different notes, and all the different notes are being hit simultaneously on this display. You might be wondering why this one here is still was still lit up for a while there. That's because in sequencer 1 I have the hold length set at a higher rate than any of the other sounds. So for example, if we go back to sequencer 3 controls, the hold length is, that one is set to the same length. Maybe some of the others aren't though. That's why that's the case. So you can already see that the loops here are actually starting. This is the you can see these are all the various loops, and they're all starting to play in different orders. It's really clear when we see it from this screen. By the way, these are all being played to with the C minor scale, and that's what's being populated here is the C minor scale. So essentially that's it. You just have this looping pattern which slowly the notes drift away from each other. And I chose this choir sound because it sounds a lot like 2-1 or 2/1 from Music for Airports. I also had to open up the attack quite a lot to give it that ambient quality, and obviously increase the release as well. But apart from that, and then I just added some basic reverb. I added some basic stereo imaging, which I ended up turning off because I got sick of it, and some basic compression that I ended up turning off because I got sick of that as well. But that was basically that. So what's happening in terms of this visual display is the various sequences are being sent to these various visualizers. So when different notes are triggered on the sequencer, on this compulsion sequencer, they're being triggered on this visualizer. And then down the bottom, I'm not sure if I showed this, down the bottom I have, this is taking the audio from the overall audio, not individual audio from individual bits, but the overall audio, and just representing it in these 4 colors. Okay, that's it for the first one. I hope that you enjoyed listening.